For 20 years, one company has been the only company on Earth that can build the machine every advanced chip on the planet depends on. Not two companies, not three. 1. ASML. Experts said replicating it from scratch would take a decade, minimum. A team in China just gave that timeline a new number. 2028. Not a decade. Not someday. A specific year on a specific machine that experts said shouldn't exist yet. Here's what's actually been verified, and what ASML's 20-year monopoly looks like now. Inside a secured building in Shenzhen, there's a machine that takes up almost an entire factory floor. New employees who work on it don't use their real names. Their ID cards carry fake identities, specifically so that if anyone outside that building ever asks who works there, the real answer doesn't exist on paper. And the machine they're building inside that room is something ASML's own CEO looked reporters in the eye and said would take China many, many years to even attempt. That machine already exists. It was finished in early 2025, and it's being tested right now. This isn't a leaked screenplay. This is a real story, reported by Reuters, built on sources with direct knowledge of a classified Chinese national security program, and once you understand exactly how they built it and exactly who they got to build it, you're going to understand why this single machine might matter more than almost anything else happening in the global chip war right now. Two things are colliding inside this story that make it genuinely different from every other China catches-up headline you've seen. And almost none of the coverage on this connected them properly. Stick around, because the twist involving who actually built this machine is the part that should really stop you. I want one word from you at the end. Cracked or copied. You'll know exactly which one you believe. Let's get into it. Here's why this specific machine matters more than almost any other piece of hardware in the entire chip industry. It's called an EUV lithography system, extreme ultraviolet lithography, and it's the single most important tool that exists for making the most advanced computer chips on Earth. It works by firing extremely precise beams of ultraviolet light through an incredibly complex optical system to carve circuit patterns onto silicon wafers, patterns thousands of times thinner than a human hair. The chips that power your phone, the servers training the world's biggest AI models, and yes, advanced weapons systems too, all depend on this exact process at the cutting edge. And for over 2 decades, exactly one company on the entire planet has known how to build a machine capable of doing this at commercial scale. ASML, based in the Netherlands. Not the market leader. Not the dominant player among several competitors. The only company that has ever actually shipped a working commercial EUV machine, full stop. Building that capability wasn't cheap or fast for ASML either. According to industry analysis, it took the company roughly 2 decades and around $10 billion in research and development, plus direct co-investment from Intel, TSMC, and Samsung, just to make EUV commercially viable in the first place. And the technology didn't even become profitable at scale until around 2018. That's the actual bar. 2 decades, $10 billion, and help from 3 of the biggest chip companies in the world, just to get one working commercial system into real factories. That's exactly why, back in 2024, ASML's own CEO publicly suggested China was still 10 to 15 years behind on this specific technology, and why more recent public estimates from Chinese government-linked publications have talked about a production-capable tool arriving around 2030, while Western intelligence assessments have often pointed toward 2032 to 2035 instead. Export controls from the United States have made sure ASML can't sell its most advanced EUV machines to China at all, precisely to keep that gap as wide as possible. For years, that strategy seemed to be working exactly as intended. Then came the report that changed the conversation. According to Reuters, inside a highly secured facility in Shenzhen, Chinese researchers completed a prototype EUV lithography machine in early 2025, and it's now in active testing. The system generates 13.5 nanometer EUV light using the same laser-produced plasma method ASML's own machines use, and according to people familiar with the project, it was built by a team largely composed of former ASML engineers who reverse-engineered the company's own technology to recreate it. Here's where the two shocks in this story actually collide, and it's the part almost nobody covering this connected properly. Shock number one is that the machine exists at all, years ahead of the public timeline experts assumed. Shock number two is exactly who built it. This wasn't a purely homegrown Chinese engineering team working from scratch, quietly grinding away in isolation for years, the way most of these stories get told. According to Reuters sources, China ran a targeted recruitment campaign starting back in 2019, offering signing bonuses in the range of 3 to 5 million yuan, along with housing subsidies, specifically to pull experienced optics and lithography engineers away from companies like ASML. One of the people who reportedly joined was Lin Nan, ASML's own former head of light source technology, the exact division responsible for generating the ultraviolet light the entire machine depends on. After joining the Chinese effort, Lin's new team reportedly filed 8 EUV-related patents in just 18 months. Some of the people recruited into this program had spent years abroad, and sources say some naturalized citizens were reportedly issued Chinese passports, despite China's official ban on dual citizenship, specifically to bring them back into the country for this exact project. To actually build the physical prototype, the team reportedly acquired older generation ASML machines through the secondary market, through intermediaries, and disassembled them piece by piece to understand exactly how the components actually worked. Sources also mention parts from Nikon and Canon showing up inside the build, suggesting the team pulled from more than one dismantled source machine. ASML's own commercial systems weigh around 180 tons. China's team reportedly couldn't match that same compact engineering, so their prototype ended up significantly larger just to achieve similar function, an oversized, rougher version of a machine that's normally engineered down to the millimeter. According to Reuters' sourcing, this entire program falls under a 6-year national initiative directly ordered by Xi Jinping, coordinated by Ding Xuexiang, one of Xi's closest allies, with Huawei playing a central coordinating role across the network of state-linked companies and research institutions involved, reportedly spanning thousands of engineers in total. Despite China's chip ambitions being public knowledge for years, this specific Shenzhen project was reportedly kept classified as a national security program the entire time, hidden even from most people working elsewhere inside China's own semiconductor industry. Now let's be precise about what genuinely happened here, and what didn't, because both the ASML's monopoly is finished panic, and the "it's just a rough copy that doesn't matter" dismissal are each missing real pieces of this story. Here's what's true, and it matters for keeping perspective. The prototype, by multiple accounts, cannot currently produce usable commercial chips. It's missing critical ultra-precision optics normally supplied exclusively by the German company Carl Zeiss, optics that remain under export restriction and are widely considered one of the hardest parts of this entire technology to replicate. Sources say the light source power, the maturity of the optical subsystems, and the state of several critical mechanical components all remain genuinely unclear or unfinished. This isn't a machine you could plug into a factory line tomorrow and start shipping chips out of. It's closer to a proof of concept that the fundamental physics and engineering can be replicated at all, which is a real milestone, but a very different milestone than commercial readiness. China's own internal target is reportedly to have working prototype chips by 2028. But Reuters' own sources inside the project say 2030 is the more realistic date. ASML itself responded to the reporting with a fairly pointed statement, saying it's natural for companies to want to copy their technology, but that doing so isn't easy. But here's what genuinely justifies taking this seriously anyway, instead of just dismissing it as an unfinished science project. A working prototype, even a rough, oversized, incomplete one, is an entirely different category of achievement than a research paper or a government press release about future ambitions. This is physical hardware, generating real EUV light at the correct wavelength, sitting inside a real factory floor, being tested right now. The gap between having something that technically works in a lab and having something that reliably produces commercial chips at scale is genuinely enormous, and it took ASML the better part of a decade to close that exact gap, even after its own machines were technically functional. But the starting point matters enormously too, and China's starting point just moved from theoretical to physical years earlier than most Western analysts had priced in. Think about it this way. In 2024, the honest consensus among most Western analysts was that a working Chinese EUV prototype was still a distant, uncertain someday. As of this report, it's a machine sitting in a specific building with a specific completion date, being tested by a specific team whose names, minus the fake ones on their badges, are now at least partially known. There's also a genuinely serious angle to this story that goes beyond engineering entirely. Dutch intelligence services warned in an April report this year that China has run extensive espionage programs specifically targeting Western technology and knowledge, including what they described as recruiting Western scientists and employees directly out of high-tech companies. Reuters reported it could not determine whether any legal action has actually been taken against the former ASML employees connected to this specific program. ASML, for its part, says it protects its most sensitive EUV knowledge internally by restricting access to only a select group of employees, even inside its own company. Whether that internal safeguard actually held up against a coordinated, state-backed, multi-year recruitment campaign is exactly the uncomfortable question this entire story raises. In response to concerns exactly like this one, the Dutch government has reportedly begun actively screening research institutions and technology transfers specifically to prevent sensitive semiconductor knowledge from leaving the country. A policy shift that's already slowed parts of China's broader chip sector and reportedly restricted how advanced Huawei's own production can get using legitimately imported equipment. It's also worth putting this story next to the other major China lithography headline that's been circulating this year, because the two are easy to confuse, but represent genuinely different tiers of the same industry. Separately from this EUV prototype, Chinese firms have already begun mass-producing and delivering DUV lithography machines, a less advanced category of equipment, to real chip factories at real commercial volume. That DUV progress is confirmed, public, and already inside working factories today. This Shenzhen EUV project is a completely different, far more advanced tier of technology, still stuck at the prototype stage, still missing critical components, and still years away from any equivalent commercial reality. Confusing the two makes China's overall position look either far more advanced or far less advanced than it actually is, depending on which story you happen to hear first. So, where does this actually go from here? Watch whether China's Shenzhen team can actually source or domestically replicate precision optics anywhere close to what Zeiss currently supplies ASML. Because multiple experts specifically flagged that piece as the hardest remaining barrier, not the light source itself. Optics at this level require polishing mirrors to a smoothness measured in atoms, a manufacturing discipline Zeiss has refined over decades, and reverse engineering that particular piece is a fundamentally different challenge than reverse engineering a laser chamber. Watch the 2028 versus 2030 timeline gap closely too, because whichever date turns out closer to reality will say a lot about how much this recruitment strategy genuinely accelerated things versus how much distance remains. And watch how the Dutch and American governments respond on the counterintelligence side. Because if this story confirms that experienced engineers can be recruited out of a company's most guarded division and used to reverse engineer its core technology within a matter of years, that changes how every advanced technology company on Earth has to think about protecting its own talent, not just its patents. Expect tighter restrictions on former employee mobility, more aggressive screening of research partnerships, and quite possibly new legal scrutiny aimed specifically at engineers who left Western lithography companies for opportunities in China over the past several years. Let's bring this together, because individually these are just details, but stacked on top of each other, they describe something genuinely significant. One prototype machine, completed in early 2025, years ahead of public expectations. 10 to 15 years. How far behind ASML's own CEO publicly said China was back in 2024. 2 decades and $10 billion. What it actually took ASML to build this technology the first time. 6 years. The length of the national program Xi Jinping reportedly ordered to close that exact gap. 3 to 5 million yuan. The signing bonuses reportedly used to recruit engineers straight out of ASML. 8 patents, filed in 18 months, by a team led by ASML's own former head of light source technology. 180 tons, the weight of ASML's real machine, next to a Chinese prototype too oversized to match it. 2028 versus 2030. China's internal target against what Reuters' own sources call the more realistic date. Individually, these are just facts about a lab in Shenzhen and a recruitment campaign that started 6 years ago. Together, they describe a monopoly that took 20 years and $10 billion to build, being challenged by a machine built substantially faster, using the exact people who helped build the original. If this video actually helped you understand what's really happening underneath this headline better than the panic or the dismissal did, hit subscribe right now, because I'm tracking exactly how this timeline, the optics bottleneck, and the counterintelligence fallout play out over the coming months. And you don't want to be the last one to find out. Drop a comment with one word. Cracked. If you think ASML's monopoly is genuinely broken. Copied. If you think this stays an incomplete prototype that never closes the real gap. I'm reading every single one of them. Thanks for watching, and I'll see you in the next one.